Hello and welcome back to Calculus 1, section 2.6 on continuity. I can never figure out which class I'm in fast enough. So continuity, that would be, most of the people like to think of continuity if you can draw the function in one stroke, it will be continuous. If there are any breaks, jumps or whatever, it's discontinuous. For the most part, that is true, and it's okay to think that way. However, when you take advanced calculus, you get to find some functions that you actually have to draw in pieces. They're still continuous, but you have to draw them in pieces. So, yeah, we can technically say that something that looks like this, right, for f of x, would be continuous. And something that would look like this would be not continuous, or we say discontinuous, whatever. Discontinuous. And there will be a point A on x-axis where that discontinuity happens. So we will be able to locate that value and say the function is broken, right, discontinuous, at that point. Where if you look at the left side, it seems that f of x is continuous at all points along the line. And we would like to also figure out the way to, compute continuity, or to show that the function is not continuous. So we start with the definition of the continuity at the point, and I'll say x equals a. So that's that value that you are examining, and then at a, the function will be continuous or it will be discontinuous. So it goes like this. Function f of x is continuous at x equals a if, and now you have three rules that you have to check every time you are faced with this. So number one, f of a exists. Number two, limit of f of x as x goes to a exists. And number three, limit of f of x as x goes to a is equal to f of a. So those are the three rules that will show that the function is continuous. So function is continuous. Otherwise, f of x is not continuous. At x equals a. So this is our definition. And we have now something to compute. Now, before we go on, sometimes I ask, for 3 points on the test, students to state this definition. And then I see some really scary things where some students are not clear on a difference between f of x and f of a. And then I find f of a in the wrong spot and f of x in the wrong spot. So f of x is the name of the function. F of a is the y value. So if you are to write y equals f of x from your pre-calculus, that's just a name for the function. And then you can say f of x is x squared plus 3, let's say, right? Now, you can plug in over here x equals a, and that will output f of a. in our case, a squared plus 3. So if a is, let's say, 4, you would have 4 squared plus 3, which is 19. So for this particular example here, your a is equal to 4, and your f of a is equal to 19. So anytime when you see a, b, and c, and f of a, f of b, those are numbers, particular numbers. F of x is a name which actually is a function, so anything can be plugged in. So there is a difference between f of a and f of x, and I'm just going to write over here that f of x is not this, that's bad thing to write, because we need limit of f of x to be equal to f of a. So now, over here, for the rule number 1, f of a exists. This simply means that the y value has to exist when you plug in a number in the formula. So we had in an example down there, we said that f of 4 was 19. So just the presence of that 19, we don't care the value, we just wanted to know that it exists. So it's 19 or it's 7 or it's half, it's something, right? But it exists. Can you have a situation when that does not exist? Yes, right? You don't have